All right, so you may have heard of athletes burning calories when they exercise. So a calorie is a unit of energy used in the field of nutrition. The average banana contains about 100 calories. Now, calories are really it's a measurement of energy. Okay, so when you burn calories, what they're saying is that you've consumed energy. So if you eat a banana, you provide your body with about 100 calories to burn. This energy is released in a series of chemical reactions that take place inside your body. A much faster way of releasing the energy contained in the banana is to burn it outside the body in a combustion reaction. So we're basically inside of our body, we're not combusting bananas, but we're releasing the chemical energy inside of the banana. The total amount of energy released is the same in both cases. So if I take a banana and throw it in a fire, it'll release about 100 calories of energy. Okay? If I eat it, it'll release it in my body. So what does the reaction rate tell you? Well, a reaction rate is the rate in which the reactants change into products over time. So take note of that, because this is one of the questions on your reading guide today. So reaction rates tell you how fast the reaction is going. So burning the banana will be much faster than eating the banana. You guys have acid in your stomach that starts to decompose food. When that chemical process starts to begin, you're basically breaking down those chemical bonds and releasing energy. You're taking the banana and breaking it down into its elements that our body uses the energy for. So any change that happens over a period of time can be expressed as a rate. I'm going to say that again because it's on your reading guide. Any change that happens over a period of time can be expressed as a rate. The reaction rate, this is also another one on the reading guide, is how fast the reactants are being consumed, how fast the products are being formed, how fast energy is being absorbed or released. What factors cause reaction rates to change? Well, factors that affect reaction rates include temperature, surface area, concentration, stirring, and catalysts. So the reaction rate of a chemical reaction depends on how often reactants particles collide. So if the collision occurs more frequently, then the reaction rate increases. So these elements, these compounds need to come into contact with each other in order for a chemical reaction to take place. The more likely they collide into each other, the more likely that'll speed up the rate. Okay? If the collisions occurred less frequently, then the reaction decreases, right? You got to have, if I said everybody in here stand up and shake everybody's hand, you have to physically move and get over to somebody to shake their hand. It's kind of the same with a chemical reaction. Reaction rates can change by varying conditions. Temperature is a big one. Generally, an increase in temperature will increase the reaction rate, while a decrease in temperature will decrease the reaction rate. If you store milk in a refrigerator to slow down the reactions that cause milk to spoil, the rate of spoiling decreases if milk is kept cold. So this is a good one because I keep my refrigerator at home very cold, and my milk is good usually a week after the due date because it's very cold. It slows down the process. There's other stuff too that takes place, but that's why we refrigerate some things. The milk will go bad eventually if I leave it in my fridge long enough, but it slows down that chemical process. Increasing the temperature of a substance causes the particles to move faster. On average, particles that move faster are both more likely to collide and more likely to react. If the number of collisions that produce reactions increases, then the reaction rate increases. Surface area is another big one. The smaller the particle size of a given mass, the larger its surface area. So an increased surface area increases collisions involve reacting particles. There's more stuff that can come into contact, all right? The more collisions, the more particles will react. This fire was a combustion reaction in grain dust and between grain dust and oxygen. The rate of combustion was very rapid due to small particle size and grain dust. One of the worst things is sawdust. There's a really cool thing that you could do with creamer. Creamer, non-dairy creamer, like Coffee Mate or whatever, it blows up. It's because it's such a fine powder. You have more surface area because you have smaller particles. There's more of the reactant that comes into contact with the oxygen. Now, if I filled this silo with just big chunks of wood, it would take a really long time. If I filled it with sawdust, it would go up in seconds. That's what they're trying to say. Because the surface area of a big chunk of wood, there's a lot of molecules on the inside of the big chunk of wood that aren't coming into contact with the oxygen. You have to burn the outer layers of the wood to get to the inner molecules. However, if you have sawdust, you don't have to burn through so many layers. There's a lot of surface area. That's the point. Stirring reactants increases their exposure to each other. In a washing machine, particles of detergent react with particles of stains on clothes. The washing machine speeds up the reaction by stirring the contents back and forth. That's all you're doing. It's causing that soapy water to come into contact with the dirt, oil, and grease. The soap absorbs the dirt, oil, and grease, and so you just agitate it. Also, do you guys remember when Mr. Adams did the demonstration on filtration? Remember I put the stirring thing in the beaker and that kept it spinning, and I said the reason I did that was to move the molecules around. Concentration. This refers to the number of particles in a given volume. You can change the reaction rate by changing the concentration of reactants. The more reacting particles that are present in a given volume, the more opportunities for collisions involving particles. The reaction rate is faster. So this really, a lot of times, we dilute things to make sure they're safe. So if for example, young ladies that use nail polish remover, that's basically acetone. And acetone, if it's in its most concentrated form, you really don't want to put on your hands or your body, so they dilute it with water. Now, you can make the acetone stronger or weaker depending on how much the concentration is. So a lot of times we dilute things so it's safe for our body, okay? But if you were to dip your, like if you wanted to remove the fingernail polish on your hand with pure acetone,
Most of us do it like that.
huh?
Most of us do it like that.
Well, even the stuff that you buy is diluted.
Oh, yeah.
Like rubbing alcohol is another example. Remember how with the pandemic everybody's talking about it's got to be at least 70%? Well, the other 30% is water, usually. So the higher the concentration, the more of the reactant is available. And a lot of times we will dissolve things purposefully to slow down the reaction. Okay. So a dye solution in the left beaker is more concentrated than the dye in the right. Increasing the concentration of the dye increases the rate of color change. So here, well, let me back up. So basically what they're saying is look at this white cloth here and look at this white cloth here. If you dip it into a heavier concentration, this will get darker quicker than this one will. Now, if you leave them in there long enough, this will soak up just as much dye from the solution as this one will, but this one will do it quicker. So for gases, concentration changes with pressure, right? The ideal gas law, remember all those gas laws we talked about? The greater the pressure of a gaseous reactant, the greater the concentration. Now remember, pressure is just the molecules bouncing off the surface. So the greater the pressure, the more the molecules are bouncing. That means that they're going to be moving faster and they're going to react because they're going to be colliding faster. A catalyst. This is also on the reading guide. This is a very specific word. Basically, a catalyst is a substance that affects the reaction rate without being used up in the reaction. Chemists often use catalysts to speed up the reaction or enable the reaction to occur in a lower temperature. Every car manufactured has a catalytic converter. There's certain metals in that catalytic converter that kind of process the exhaust of the car to make the exhaust that comes out on the other end a little cleaner. A catalyst doesn't necessarily get used up in the process. It's just something that sparks it. So yesterday we used the example of a propane tank and a propane grill, and you just take a spark that starts the reaction. A catalyst is the spark, but it's a chemical. It's something that starts the reaction. So one of the steps involving the making of sulfuric acid is the reaction of sulfur dioxide with oxygen to form sulfur trioxide. This reaction happens very slowly without a catalyst, such as I can never pronounce this, vanadium oxide, this thing. All right. So the catalyst is neither a reactant nor a product, so it is written over the arrow. So this is an equation that's balanced, and we kind of put this in the mix because it kind of acts as, it's a catalyst. Okay. So then what does a catalyst do? Well, catalyst lowers the amount of energy required for effective collisions between the reacting particles. So you have the reactants here. We need to release some chemical energy. So there's an energy barrier that exists without the calculus. Normally that energy barrier is here. So when you add the calculus, what we're doing is we're lowering, the green line is with the catalyst. I don't know why I keep saying calculus. When you add the catalyst, what it does is it lowers that energy barrier, and that causes the reaction to move quicker. It increases the reaction rate. So just to recap, which of the following changes will decrease the rate of a chemical reaction? Increasing the temperature only increases the rate. Grinding the reactant into the fine powder will increase the rate because you're creating more surface area. Stirring the reaction mixture will increase it, decreasing the concentration. So I think D. Anything that you increase usually increases the reaction rate. So yep, D. The reaction rate is the rate in which the reactions change into products over time. Yeah, that's true. And that's all I got for you guys today. Okay, so